Hey guys, welcome back. So what we're looking at today is lesson 11, filling containers. So we're looking at three-dimensional figures or three-dimensional cylinders really, and looking at comparing how they grow when we take and fill them. Now we aren't actually going to take and do the activity of filling them, but I'm going to show you kind of what it looks like and what affects it and what makes it so it grows faster or grows slower. So let's go ahead and jump right in. So this is if we would have done the activity of taking and filling different cylinders with water and calculating their volume and their height. This is what we would have found. So this right here is showing different cylinders and their volumes. And so if we look at this, some of them are growing at a faster rate. So like this black one here is filling much faster than what the blue and the yellow ones are. So that's what happens. It fills faster. The so it'll fill faster the narrower, the smaller the radius. It will end up filling quicker than it will when it's wider. So the smaller a radius, the smaller across the cylinder it is, the faster it fills. And then the wider it is, the slower it will fill. But it will be a proportional relationship, as you guys should know, since if we have no water, we have no volume. If we have zero for radius and height and all that, then we're not going to have a volume either. All right, so what's the shape? The graph shows the height versus volume function of an unknown container. What shape could this container have? Explain how you know and draw a possible container. And then notice, we have it going at a pretty fast rate here, and then it kind of slows off in how fast it's growing. Now, we are dealing with cylinders, so this is going to be a cylinder or multiple cylinders together to represent this. So for this first part, is it going to be a narrow cylinder or is it going to be a wider cylinder based on how fast it's going? It's going to be on the narrower side because this is growing really, really fast. So rough sketch, do not judge me because I'm terrible at drawing, especially on here. Whoops. Let's make it so you can actually see that. So we're going to have kind of a narrow cylinder, something like like I said, terrible at drawing. So we've got our cylinder, but then what happens here? It starts slowing down how fast it's getting filled. Now, why would it suddenly start slowing down? Well, what if we put another cylinder on top of this and it fills from one down into the other? Then it's going to take, and we'd have the bottom would fill first, so the lower, smaller cylinder would fill first, and then the other cylinder will fill on top of that. So let's say, oh goodness, I'm trying to draw this. Something, oh goodness, this is terrible. Something like this. And here, I'm going to show you guys my drawing that I have on paper because hopefully it will make more sense. So this drawing right here, I know it looks kind of weird, but we've got a cylinder on top of another cylinder. It's hard to figure out. The one on top is going to be much wider than the one on the bottom. That's the key thing there is the shape. So the shape's going to be in the form of two cylinders stacked on top of each other with the upper cylinder having a much greater radius than the bottom cylinder. So looking at question 2, the graph shows the height versus volume function of a different unknown container. What shape could this container have? Explain how you know and draw a possible container. So if we look at this next one, notice what's happening here. We've got it growing, suddenly grows faster, then grows much slower. So we've got 3 different rates. What do you think about this? We're going to have how many different cylinders? Well, we'll have 3, I'm just going to write out a description of it rather than trying to draw it. 3 cylinders stacked on top of each other. Bottom cylinder is going to be the tallest. And so it's going to be the tallest, and it's going to have the smallest radius. So smallest, or small radius, not the smallest. Small radius. middle cylinder shorter and smallest radius. Oops, radius. And then the top cylinder will be the shortest. Oops, shortest and largest radius because it has the shallowest slope. So notice it's taking the height is going up by 4 over the course of a, look at that difference, a 30 millimeter difference in volume. Whereas in this one, it's a 10 millimeter difference and it's going up 2, 4, 6. So much different relationship there. So for number 3, how are the two containers similar? How are they different? So both are made up of multiple cylinders. So both contain multiple cylinders. How they're different is first in 2 parts, second in 3. So one has more cylinders that it has to go through, more changes with those different amounts. We also have some that are going faster than others in there, so some differences between them. But this is what it looks like in comparing sizes of cylinders to their graphs of their volume versus height. So the steeper it is, that means the smaller the radius. And then the shallower it is, like this here, that's going to be the larger the radius. So your keyword for this lesson is volume. Volume is your keyword for this lesson. If you guys have any questions, feel free to ask. Have a great day.